Today we are talking about something called direct variation. Direct variation is just a form of an equation. It happens to be a proportional equation, which we'll talk more about in a later section, but it's going to look like this, where it's y equals some number times x. There's no addition or subtraction, just y equals some number times x. Direct variation equations will always go through the origin, so it'll always go through 0, 0. So numbers 1 and 2 says determine the constant of variation for each equation. The constant of variation is just the slope. It can also be the k in the equation, so whatever number is in front of your x in the equation. So for number 1, my equation is already written for me. So if I look at this, my constant variation is the number in front of the x, 3. So I know that it's going to be 3. But the way that they figured that out was you could pick any 2 points on the graph. So I'm going to pick 0, 0, and 1, 3. And you can either use your 2 points, subtract your y's on top, subtract your x's on bottom, or you can do rise over run. So from your left points, always your left point, figure out how many did I rise. I rose 3. How many did I run? 1. So 3 over 1 is 3. So the constant variation, again, is just the same as your slope. So if we look at number 2, the equation is not given to us this time. So we picked 2 points, so I'm going to pick 0, 0 again, and 1, negative 2. And you can do rise over run, so start with your left point. Figure out how many did you rise. You rose a negative 2, and you ran 1. So that's negative 2 over 1, which is negative 2. And just as a reminder, you also could have done 2 points. So if I still pick 0, 0 and 1, negative 2, subtract your y's on top, so negative 2 minus 0, subtract your x's on bottom, 1 minus 0, to still get negative 2 over 1, which is still negative 2. So whichever method you prefer, just pick that method. Now the next 3 examples, we're not going to be given a graph, we're going to be given information about the equation. So it says y varies directly as x. That word varies directly tells us it's a direct variation equation. So I know it needs to look like y equals some number times x. So what I'm going to do is plug in these numbers, y equals 72 and x equals 8, and figure out what is k. So I'm going to plug in 72. I don't know k yet. I know x is 8. So I'm going to divide both sides by 8 to get k by itself. And we get k equals 9. Now it says to write a direct variation equation. So the equation is just going to be this. But since I know k is 9, I'm going to put 9 in for k. So this is the direct variation equation. The next thing it asks is to use that equation that we just made and figure out what would x be when y is 63. So if I plug in 63, got 9, and I don't know x, divide both sides by 9, I get x equals 7. So there were 2 answers to that. You had to come up with the equation and then figure out what would a certain variable be if another variable was number. This is useful just because using this we don't have to make a graph where normally we would. You just come up with your equation and then you can plug in whatever number they say to figure out what your x or your y would be. Number 2, suppose y varies directly as x, so again, direct variation. Y equals 98, x equals 14. So I'm going to start off with my basic equation, y equals k times x, and plug these numbers in. So y is 98, don't know k yet, x is 14. Divide both sides by 14 to get k by itself. So we get k equals 98 divided by 14 is 7. So my equation, again, we're just rewriting the y equals k times x, but plugging in k, y equals 7x. So this is just your basic equation, where if you were to graph it, it would hit 98 and 14. And then they want us to figure out what would y be if x is negative 4. So we don't know y, but we do know x is negative 4. 7 times negative 4 is negative 28. Okay, the last question has two parts. One example of a direct variation equation is d equals r times t, which just means distance equals rate times time. The distance a jet travels varies directly, which we already knew this was a direct variation equation because they told us, and there was no addition or subtraction. A jet traveled 3,420 miles, so that's my distance, in 6 hours, so that's my time. The rate is how quickly it would have gone. So first write a direct variation equation. So if we're starting off with this basic equation, and again, it's direct variation just because there's no addition or subtraction, and we're going to plug in 3,420 for my distance. Don't know the rate, and I know time is 6 hours. So divide by 6. Then I know that the rate is 3,420 divided by 6 is going to give us 570. So my equation, again, rewrite the d equals r times t, but plug in your rate. So this is your direct variation equation. Part B, estimate how many hours it will take for an airliner to fly 6,500 miles. So this is my distance. I'm trying to solve for time. So I'm going to plug in the distance into the formula I just came up with, and then don't know time. They do this a lot where they have you come up with an equation and then the next step use that equation to solve for something. So divide both sides by 570 and we get time equals, that's about 11.4. So since we're talking about a story problem, is asked for how many hours, so about 11.4 hours. Okay. If you have any questions, as always, please email me.